So in the last video, still part of this lesson, we were talking about definite integrals in terms of Riemann sums. Now, I want to kind of go in a little bit better on what a definite integral is actually doing and how it's different from just plain old area. So what I'm going to do is I'm going to use basic area formulas, stuff you would have learned in middle school or geometry when you were in high school, and I'm going to try to use that information, those formulas, to calculate some definite integrals. So notice, I'm going to start off with this first one. I've already graphed my function, which is negative 2/3 x plus 4. So what I'm going to do on each of these is I'm going to calculate essentially the area under the curve for those x values. So this first one says, from 0 to 3, under this function, negative 2/3 x plus 4. So if I come up here and I look at my graph, from 0 to 3, from 0, the y-axis, to 3. Okay? So here essentially is my shape. If you notice, it's a trapezoid. We have two parallel sides, which is this side, the y-axis, and here at x equals 3, so x equals 0 and x equals 3. Those are my parallel bases. So right now I'm just going to essentially use the trapezoid formula. If you have forgotten the area of a trapezoid formula, it is 1/2 of the height times base 1 plus base 2. So let me repeat again. My bases are these two vertical sides. So this side right here, I'll call base 1. That's 2 boxes, okay? So I'm going to plug in 2 there. The other base, which I'll call the longer base, in this case is 1, 2, 3, 4 boxes. My height in this case is going to be the distance between the two bases here. So it's actually this x value. So 1, 2, 3 boxes along the x's. And then what I'm going to do is I'm just going to take half of it. So 1/2 of 3 times 2 plus 4. Well, remember your order of operations. 2 plus 4 makes 6. So we're doing half of 6 times 3. Half of 6, to make my life easy, is 3. So we're going to end up doing 3 times 3, which is 9 total. So my area here is 9 square units. All right, now I'm going to go a little bit further. The next one says from 0 to 6. So instead of stopping here at 3, I'm going to find this area from 0, which is my y-axis, all the way over here to 6. Now this time, instead of it being a trapezoid, this time the shape I'm looking for is a triangle. Okay? Again, if you've forgotten your area formula for a triangle, that one, hopefully you guys remember, is 1/2 of base times height. Now, the one thing you need to remember about that is it has to be a right angle. So there has to be a right angle between the base and the height. So in this case, my base is going to be this side, which is 1, 2, 3, 4, 5, 6 boxes, times the height, which will be my y's. So 1, 2, 3, 4 boxes. And so we're going to do 1/2 of 6 times 4. Well, 1/2 of 6 is 3 times 4 makes 12. Okay, so my area for the next section is 12. That's that whole triangle, 12 square units. The next one that I need to do goes from 6 to 9. So if I start on x equals 6, I'm going to come all the way over here to x equals 9, and this is going to be the area I look for. Now notice this is also a triangle, but unlike my triangle before, this triangle was above the x-axis. The triangle I'm looking for now is below the x-axis. So I'm still going to use the same formula. It's still a triangle. So I'm going to do 1/2 of the base. Now, again, I'm going to try to use these x's as a base. So 1, 2, 3. And now I'm going to use the height. Here's the thing in this case. My height is no longer going up. It's no longer positive. In this case, my height is going down. So really and truly, my height's negative. So I'm going to use a -2 because there's 2 boxes down here. So 1/2 of 3 times -2. Well, 1/2 of -2 is -1, so we're going to do -1 times 3, which is -3. Now, I know you guys are kind of sitting here going, but Mr. Harold, we always learned that area is positive. Well, that's true, but we're not actually calculating area really and truly at this point. Right now, we're calculating a definite integral, which is an operation, not a value. So Let me make sure I say that again. Definite integrals can be negative, especially in this case when it's below the x-axis. All right, so last one I need to do is from 0 to 9. Now, if I try to calculate this area from 0 to 9, that's going to cover everything that's shaded up here. So here's the thing. I'm going to calculate the positive part separate, which I did. It's 12. I'm going to count the negative part separate, which is negative 3. All I have to do now is combine them. 12 plus negative 3 makes 9. So my final answer here is 9. Let me repeat that one more time. Definite integrals can be negative. If there's a positive part and a negative part, you can calculate them separately and then combine the answers in the end. All right, hopefully that explains it. You guys will see me for another example in just a second.